Assalamu alaikum, everyone. Good morning, ladies and gentlemen. I'm happy to be here. I would like to start by thanking the organizers for inviting us for this first event, which is a landmark event that is really to kickstart the technology journey for PropTech. In my discussion today, I'm going to be sharing my experiences as a construction technologist and as an investor. My name is Iyad Shammas. I am a construction professional. I've been executing construction projects for around 3 decades. I'm also a clean tech expert. I am on the board of various clean tech startups and companies throughout the Middle East as well as Europe. I'm a partner in Nirman Ventures, which is a construction technology fund out of Silicon Valley that's focused on clean tech and serving the construction industry sustainability. My presentation today is going to pick up on the discussion that happened in the first discussion during this day. The last question of the first discussion, which was the sustainability and what's the industry doing and what's the PropTech industry doing in order to become sustainable and adopt the best sustainable practices. I will also focus on the convergence of both construction technology and the clean technology, and I will demonstrate how this is going to shape the future of properties and developments as we know it. In this presentation, we'll go through a quick overview of the timeline and current digital practices, as well as the consequences of the construction industry on the world we live in. And I will zoom in on practical cases where segments of technology are now serving the sustainability efforts in the construction industry. And finally, we'll conclude on the convergence between construction and sustainability in terms of current technology adoption. To take you through the timeline of the adoption of the construction industry, the industry has been slow in adopting. If we can see, the last century witnessed few numerous adoptions in technology where modularity or modular construction has emerged during the 1960s, then moving on to environmental sustainability initiatives, which gained traction during the environmental movement in the late 70s. And towards the late 1990s, we saw real technology being adopted in terms of construction software management, and moved on to BIMs in the early 2000s. And it wasn't until the last decade when we saw the adoption of the, what we say, tangible and serious technology in construction, started with BIMs, IoTs, robotics, as well as finally the adoption of AI in the industry. Why sustainability? Our industry comes at a really expensive cost, at a high cost. 40% of the annual CO2 emissions are produced as a result of the construction industry. 10% of the water consumption, as well as 36% of the energy consumption, and that's taking the whole life cycle of the buildings. Throughout my work and throughout our work as a fund, we looked at hundreds of technologies in the past 3 years, especially after the COVID pandemic. There was an explosion of technologies, especially in construction. And we as an industry benefited quite a lot from the technology and democratization of technology, particularly in terms of lowering the cost as well as having a more accessible towards the various segments of the industry. We narrowed down the subsectors that are sustainability driven or sustainability focused into 8 subsectors, and this is actually out of around 30 subsectors that the construction technology caters for. And why we have picked these is because we saw in our work that the focus, maximum interest and focus of investors as well as public institutions are focused on these industries for the development of their cities and their construction sectors. I will be going through each one of these and explaining how sustainability is now becoming an integral part of these technologies that is driving the development of construction. Starting with the green building materials, we are seeing now various products that are the basic components of construction being used and being manufactured from waste, whether it be glass or plastic or waste of construction recycled material. And that's really reducing the carbon footprint as well as providing, coming at a lower environmental cost for the industry. Energy management systems is quite a diverse domain, and we've seen hundreds of software applications that are being used, whether being measuring the carbon footprint of buildings or even looking at the energy consuming components of a building, such as chillers, heaters, as well as reducing the use of during peak times. We are also looking at communities now that are trading energy within their domiciles, where users store energy and then trade it to their neighbors during the peak hours or low peak for them. And that's being done not on an experimental level. It's becoming a fact that buildings and developments are sharing energy rather than just spending it. Modular prefabricated construction has been around for a while, as I mentioned, but it is now, we are seeing the concept of net zero homes being incorporated in the modular constructions, and efficient material are being used to build these homes that come now, right now with the label of net zero homes. And this is also as opposed to traditional modularization where you use the cement and the rebar, which has a high carbon footprint. We all heard about 3D printing. It's quite revolutionary to see that high-rise buildings go through 6, 10 floors of buildings within 6 or 10 stories of buildings within a matter of weeks. It's happening. The good thing is now this is happening with the use of sustainable material, such as waste material of glass and waste construction material is being now becoming a feedstock for 3D printing machines. And these 3D printing machines move from one site to site and do the construction on that in situ rather than being remote and having to transport the buildings or the components towards the construction site. Waste management solution is being implemented in terms of segregation, automatic segregation. Again, that's using smart systems to segregate the waste that's being produced by the buildings or commercial or residences. And in some cases, the waste is used to produce energy by converting it into a hydrogen or gas. And that's still in the experimental stage, but we see this a way and a trend in the future where the buildings will be able to produce their own energy from waste. I think we spoke many times about BIMs during the, today's sessions as well as yesterday's sessions. Here I would like to say BIM is now becoming an integral part in sustainability of design as well, whereby more smart sustainability designs are being offered using AI. For example, selecting the most efficient facade for buildings, using the most efficient material, the most optimum way to position a building based on the sun and the temperature and the daylight. So that's all being done now and incorporated by BIM, and it's becoming sustainable initiative as well, not just limited to the design of the building and let's say reducing efficiency, increasing the efficiency of the design. It's also becoming more of a sustainable initiative as well. We are seeing more sensor integration in concrete structures as well as steel structures. Various technologies now can measure the embedded CO2 content as well as the CO2 release. Developers are using CO2 sensors and pollution sensors to detect and determine the carbon footprint on construction sites and to also determine compliance with regulations throughout the building construction cycle as well as life cycle of the building. Last but not least, the new and interesting concept of engineered living material, which is the merger of biology and construction in ways that can revolutionize the architecture and material science. Examples of engineered living materials are bioconcrete and biobricks. Bioconcrete is a type of concrete that incorporates bacteria to heal the cracks over time. Biobricks are bricks that are made of living organisms, and they offer sustainability alternative to the traditional brick making process. Here, ELMs are quite new, and they're under a lot of experimentation. But I believe they would represent the future of the built environment in 3 ways. One of the ways is self-healing, where the structures can actually repair themselves. Second way is the sustainability, where engineered living materials are designed to be more sustainable than traditional synthetic material, and they can also sequester carbon and reduce the building footprints. And finally, the environmental response, which is a part of adaptability to the of the buildings to their surroundings. For example, engineered living material can be designed to regulate thermal insulation or moisture level in response to the climate. What do we conclude from this? We see that there is an intricate connection between construction technology and the clean technology, and we see the future heading towards a merger between both subsectors, whereby all or most of the construction technology will have a clean technology factor or a clean tech factor embedded into it, and that's not just a wish, that's happening, not only because of the impact, but also because this is the world we live in and we need to protect it. And as the government and the public institutions draw much more stringent targets to sustainability, the built environment has to respond, and they have to respond positively in order for them to ensure survival and competitiveness in this environment. Thank you so much for listening, and I hope you benefited from this discussion. I'm happy to answer any questions now or after the panel, and thanks again for having us in here. Thank you.